In this video, we're going to do some relations over binary strings. Now, I want you to think about what a binary string is. We're used in many programming languages. Text is considered a string, right? And so here, what we're saying is we have strings made up of binary digits. So 00101 is a binary string. 110101 is a binary string. And often we don't bother to put these little string quotation marks, and we just use the numbers. Okay, so these would be called binary strings. So we're going to define a relation A. We're going to define the set A to be the set of all binary strings of length 2. So we can draw that. Right, because there's a length 2, we're restricted to only 4 elements in our set. So set A has a size of 4, and they're all possible combinations of zeros and ones. So the relation R is defined as following. For all elements over the set A, well, these are the elements in A, I'm going to say that S is related to T via relationship R, if and only if S has the first same character as T. So let's take a look at this. Is 1, 1 related to 1, 1? Yes, because looking at their first characters, they're the same. Because 1 equals 1. Okay, how about is 0, 1 related to 1, 0? No, because the first character in both of these is not the same. Right. And in this last one, we can see that it is indeed, these two strings are indeed related because, again, 0 is equal to 0. So this is a relation on A. And what would be the domain? Well, the domain is, again, whatever elements this S could be, and we know that S is an element of A, so our domain is going to be A. And similarly, our codomain is going to be whatever T can be, and we know T is an element of A, so our codomain is A as well. So we can graph this relation R on A in a couple different ways. First is our traditional arrow diagram on the left, right? I can say that 0 is related, or 0, 0 is related to 0, 0 because they both have zeros, their first letter or first character. And same here, and here, and here. And then ones. So this is one way of showing this relation. Now, if both the domain and the codomain are the same, if the domain equals the codomain, we can say this is a relation over that set. And what we can do is we can then draw the elements of the set and connect them in a graph. So here, 0, 0 is related to 0, 1, and similarly, 0, 1 is related to 0, 0. 0, 0 is also related to itself, and so is 1. And down here, 1, 0 is related to 1, 1, and 1, 1 is related to 1, 0, and they're both also, this is called self-referential. They both point to themselves because they're both related to themselves. So we can only do this if there's only a single set that both the codomain and the domain fit. Otherwise, you really have to do this arrow diagram. But if the codomain and the domain are the same, we can do this. And so this is a relation over A, and we've just graphed it. So let's look at a different relation over binary strings. I'm going to say B is the set of all binary strings. So B is an infinite set. And I'm going to define a new relation R on B such that two elements of B are related if they are inverses of one another. So what does that mean? Well, the inverse of a string is going to be if we reverse it. Okay, so looking at these 3 questions down here, is 1, 1 related to 1, 1? Yes, right? Because if I flip them, if I make them 1, 1 go in reverse, we still get 1, 1. How about this one here, this next one? We have a 0 on the outside there, and then 2 1s there, 0, 0, 1, 1. So this is also an inverse. Let's look at this last one. Okay, we have 2 zeros, and then a 1, and then a 0. But now we have 2 1s, and here's only 1, 1. So these are not inverses of each other. Right? So this is a relation that requires these to be inverses of each other. Now notice we can't graph this because B is an infinite set. You could do it if you limited the size of the binary strings.